Welcome to the 6th episode of the Grand Cosmic Story. Do you know how our universe would have been before its expansion? And how it would be in the future? Will there be an end to our universe? If there is an end, how and when will it happen?
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
There are around 2 trillion galaxies in the observable universe, and even our wildest imagination cannot fathom the vastness of space. That is why the exploration of space is so exciting. Since 1960, our knowledge about the universe has expanded thanks to the host of space telescopes operating in multiple frequency bands. But still, many aspects of the universe remain mysterious and are not susceptible to explanations based on the knowledge available to us at present. No one knows, for instance, what the universe was like before it started expanding and what will happen in the distant future. The end of our universe is mysterious as the beginning of our universe. Scientists were wondering how the fundamental particles that constituted the baby universe and were initially massless gained mass. Do you know that your mass is the same wherever you go in the universe? Your weight, on the other hand, changes from place to place because of the change in gravity. Now, where did this mass come from? What is its origin? How did we all gain mass? If you have ever struggled with a stalled car or a stalled motorbike and you have tried to manually push your vehicle, you would have felt the resistance. This is called the mass. In the context of Newton's second law, mass is a measure of the inertia of an object. If you look at your car at the atomic level, its mass comes from the molecules and atoms made from fundamental particles like electrons and quarks. But where do the masses of these fundamental particles come from? If you manually push a ping pong ball that is submerged in water, you will find that it is considerably heavier than outside the water. In the same way, the British theoretical physicist Peter Higgs and a few of his contemporaries put forward an idea in the 1960s that the particles that were massless at the beginning gained mass around 10 to 12 seconds after the Big Bang because of their interaction with an invisible field. This invisible field was named the Higgs field and is associated with a particle called the Higgs boson. Some scientists even feel that the Higgs boson could be the secret ingredient that gave inertia to the entire universe as the infant universe suddenly ballooned in a fraction of a second to many orders of magnitude. Particle physicists started to search for the secret ingredient. In 2008, they built the world's largest machine, the largest particle accelerator, the Large Hadron Collider at CERN in Geneva, Switzerland. The collider is contained in a circular tunnel with a circumference of 26.7 kilometers at a depth ranging from 50 to 175 meters underground beneath the border of Switzerland and France. There are around 9,000 superconducting magnets that surround the collider. These magnets help accelerate two groups of protons to exceedingly high energies so that they smash head-on, producing tiny subatomic particles. With the help of the Large Hadron Collider, on the 4th of July 2012, particle physicists detected the evidence of the existence of the Higgs boson. Since they struggled hard to detect this particle, the Nobel Prize winning physicist Leon Lederman referred to it as the goddamn particle, which later became the God particle. When Higgs boson was discovered, many Indian newspapers pointed out the fact that the word boson had been coined after Satyendranath Bose from India. This is because Satyendranath Bose carried out revolutionary work in the area of quantum statistics in 1924, and the particles that obey quantum statistics are named after him as bosons. When the Higgs boson was discovered, scientists were intrigued by the value of its mass, which is 125 giga-electron volts, because the stability of the universe seems to depend on this value. They found that due to this value, we are almost at the critical boundary between a stable universe and a metastable universe. A metastable universe is a universe in a false vacuum state that is not stable but can decay any time. The late Stephen Hawking said that the Higgs boson could one day be responsible for the destruction of the known universe, and he called that day the Higgs boson doomsday. In other words, as per this understanding, the fate of the universe depends quite sensitively on the mass of Higgs boson. Another mystery is that this great cosmic ocean with its 100 billion galaxies and stars make up just 5% of the total mass and energy in the universe. The rest is unseen and unknown, which scientists have dubbed as dark matter and dark energy. What is this dark energy and what is this dark matter? Is dark energy the strange energy of empty space or something entirely new? More is unknown about it than is known. Scientists believe that dark matter, or the universe's hidden architecture, emits no light and that it does not interact with light. It is dark and radically different from normal matter found in the planets and stars that we see. Scientists have hypothesized that this dark matter might have been made of what they have called as weakly interactive massive particles, or WIMPs. This WIMPs might be many times heavier than the proton. However, several experiments have failed to find evidence for WIMPs. But how are scientists so sure of this dark matter and dark energy? Using a set of telescopes in Chile, Hawaii, and the Canary Islands, two different teams of astronomers made new measurements of distant galaxies that existed 7 billion years ago, and all of them announced the same surprising discovery. The galaxies appear to be moving apart from each other faster and faster. The expansion of the universe was speeding up. Some of the galaxies appeared to move so fast that they seemed to have been ripped apart. This discovery of the accelerating expansion of the universe was as peculiar as if you threw a ball in the air and it sped up and flew away from your hand into the sky. However, scientists are unable to find the cause behind this acceleration of the expansion of the universe. It's possible that there might be some sort of unknown, invisible matter in the universe, something out there that holds swarms of galaxies together in place and keeps their stars from flying apart. This entity has been dubbed as dark matter, and it makes up to around 27% of all matter. This dark matter tends to pull the universe together. There is another ingredient which makes up to around 68% of the universe that tends to drive the universe apart, and that is what is called dark energy. Briefly, dark matter attracts and dark energy repels. While dark matter pulls matter inward, dark energy pushes it outward. To understand this cosmic struggle, we need major experimental and theoretical breakthroughs. Although dark matter and dark energy appear to be competing forces in our universe, they were both forged in the Big Bang and both remain mysterious. Michael Turner, who coined the term dark energy, believes that this dark energy has the destiny of the universe in its hands. As it will make our universe grow eventually darker and emptier by speeding up the stretching of space. But when will our universe be ripped apart? This mystery is yet to be resolved. Another mystery is why we are placed in such a strategic place in our galaxy where intelligent life like us can thrive and also in a place that can give us a clear cosmic window to look into the other galaxies and study this vast universe and understand why we are here. First of all, what is a galaxy? A galaxy is a big bunch of stars that are connected by gravity, and they can be classified into two main types, spiral and elliptical, based on their shapes. The age of most of the galaxies is between 10 billion to 13.6 billion years, since they were formed when our universe was quite young. Our nearest neighbors, the large and small Magellanic Clouds, which are two irregular dwarf galaxies, can be seen from the southern hemisphere even without using a telescope. The next galaxy bright enough to be seen by the naked eye on dark moonless night is the spiral Andromeda Galaxy, also called as M31. This is a beautiful and most detailed image of the spiral M51 galaxy. It is nicknamed the Whirlpool Galaxy due to the grand design of its striking winding and swirling structure. Located about 23 million light years from us and around 38,000 light years across, we have a beautiful view of this galaxy as it is located in space, perfectly spaced on to our Earth. At certain times of the year, from specific locations, even our own Milky Way galaxy can be seen. For hundreds of years, many have stood in awe, staring at the Milky Way galaxy up at the night sky. The picture of the Milky Way with its stars looks very beautiful, arching across the horizon with the center rising high in the sky, invoking a sense of wonder in us. But what is the shape of a galaxy? Sitting within the galaxy, is it possible to find its shape? Trying to observe the shape of our own galaxy is like trying to look at the tip of our nose and deciding its shape. But our scientists have made great strides and have found that our Milky Way is a spiral galaxy that is around 100,000 to 120,000 light years in diameter and about 1,000 light years thick. The number of stars in our galaxy is around 400 billion. If you try to count all of them one by one, it would take around 2,500 years. Our Milky Way galaxy has 4 large spiral arms that contain places where new stars are being formed and old ones are dying as supernovas. And our sun is located about 2/3 of the way outward from the center between the two major arms, the Sagittarius and the Perseus arms, and in the inner rim of a minor arm called the Orion arm. What happens if we move from our present position towards the center of our galaxy? As we approach the center, we can find a supermassive black hole named Sagittarius A with a mass of about 4 million times the mass of our sun. Sagittarius A is a brooding behemoth, and we can see clouds of gas and dust falling into it. This black hole is in the process of growing, and it can grow over the next several billion years by devouring nearby stars and gas clouds in the crowded central region. But since we are roughly 26,000 light years away from the black hole, it cannot devour us. The center of a galaxy is a very dangerous place. We are located in that particular region of the galaxy where intelligent life can thrive because it's enriched with metals, and it is also far away from thriving black holes and exploding supernovae. Scientists are intrigued about this position of our solar system within our Milky Way galaxy because this position is not only special for intelligent life to exist but also enables us to study our universe. Scientists have also researched to find out if our Milky Way galaxy will one day end or if it will expand into space forever. Though space looks very beautiful and serene from the Earth, in reality it's a place of violent collisions between supermassive celestial bodies. Many clusters of galaxies constantly move, being stretched in all directions, at times colliding with one another, giving a dazzling display. New research conducted by the Eagle Project predicts a collision between our Milky Way galaxy and the large Magellanic Cloud, which is expected to take place some 2 billion years from now. This would completely dislodge our solar system and bring an end to all of us. If that doesn't happen, it is expected that after about 8 billion years, our Milky Way might crash into the Andromeda Galaxy. Anyhow, much before that, we will face our end in this universe. It is the elusiveness of the meaning that haunts us, that sends us again and again into the natural world where the key to the riddle is hidden. says a famous quote from the book The Edge of the Sea by Rachel Carson. Some of the cosmic mysteries that I have highlighted today incite wonder, motivating our search for meaning and connecting us with the question of our existence. It's quite obvious that underlying the beauty and wonder in the universe, there is also meaning and significance. If there is a meaning and significance to our beautiful universe and life, someone should have created it purposefully, and someone should have put us in this universe also with a purpose.
The heavens declare the glory of God, and the firmament shows his handiwork. Day unto day utters speech, and night unto night reveals knowledge. There is no speech nor language where their voice is not heard.
Bye for now. See you again in the next episode.